Now in the last video, we took a look at example number 8. And in this example, we took a whole bunch of information off of a first derivative and second derivative for a function, and we were able to sketch a very accurate picture of a graph. Now, you might be thinking to yourself a couple things. First off, you might be thinking, gosh, if this was on an exam and I needed to know all this information, I should really know what my first and second derivatives do. That's definitely true. But you might also be thinking, wait a minute, if this was on an exam, then couldn't I just really easily just go to Desmos or go to my calculator or whatever it is, and I could just figure out exactly what the equation looks like and then just sketch it on the page. Like you could maybe reverse engineer the solution. And I think you're 100% right, which is why something like example 9 is going to exist. Take a look at example number 9. Notice in here, I am never going to tell you what the function f actually is, but I am going to give you all of the information necessary to be able to sketch me a possible picture of what this function might look like. Let's go ahead and try to summarize all the information we've been given, almost like what we did previously in example 8. I'm going to separate out information based on what I'm given related to the first derivative, and then I'll separate information out for what I know about the second derivative, and then I'll try to sketch a picture over on the side. Let's see what we got. All right, so notice that my first line here tells me something about my first derivative. It apparently tells me that if I was to go ahead and draw a number line out here, that from negative infinity over to 1, okay, my first derivative is positive. Okay, so from negative infinity over to 1, my graph is positive, or f prime is positive. And from 1 onward, I know that it is negative. So this is interesting. This tells me that my graph here is going up and then going down, so I know that there's a max at the value of 1. Okay, well what about my second derivative? Second derivative. Now over here, I'm told that my second derivative is positive from negative infinity to negative 2. So from negative infinity to negative 2, I get a positive second derivative. But then also from 2 to infinity, so let's put 2 on here. From 2 to infinity, it's also positive. But in between those, it comes out negative. So this tells me about concavity. I know my graph is concave up. I know my graph is concave down. And I know my graph is concave up. Okay, great. But this third part here tells me something interesting. Remember, this is telling me some stuff about limits, like where the graph is ending. So this information here is really going to only be about the end behavior of the graph. And we'll tackle this last. Let's see if I can almost mimic exactly what we did in the previous example to try to get a possible sketch of what this picture could look like. So let me go ahead and try to set this up here. Let's see what we have. So I know that at 1, I should have a maximum. So let me go ahead and just try to eyeball where this would be. Let's say I have a maximum like right here. Okay, I don't know where it is, but I'm just sketching a possible picture. Now I know immediately that I should also have some inflection points on my picture, say at negative 2 and at positive 2. So let's say, I don't know, I get something that looks like this, and then maybe over here I get something like at negative 2. Maybe negative 2 would be a little bit further over here if I'm trying to scale this. Negative 2 might be like over here, and maybe I get a, I don't know, let's say like a point down here. Okay, so I don't really know where to put these, but if they don't end up in the right position, I can always end up adjusting them. So now let's go ahead and focus on the first derivative. Remember, I like to do this piece first. So this is going to say that I should go ahead and have my graph be increasing from 0 all the way, or sorry, from negative infinity all the way to 1. So okay, so I'm going to have a graph that's increasing, right? I go through this point, and then I go all the way up to here, increasing. Then I should go decreasing. So I decrease all the way to here, and then all the way down. Great. So now that I have this, let's start to put some shape into it. From negative infinity to negative 2, I should have this portion of my graph in a bending upward sort of fashion. Okay, so what that would mean is I would just need to have it kind of look, I don't know, maybe something like, well, notice I can't turn here because that would create a minimum, so I have to still leave it always going down. But I can kind of do that by maybe just doing something kind of like this, right? I bend it so it's kind of like the right side of this, parabola E sort of shape. So I've kind of reworked this part. Now from -2 to 2, I should have a downward facing direction. So let's go ahead and try to reshape that. So maybe from here, my graph kind of goes up. Wait, but this is supposed to be a maximum. So maybe I should kind of be careful on how I sketch that. So this is kind of the highest point that I reach. And then once I reach that point, I go down to here. Okay, so concave down. Well, now I see that from 2 on, I should be concave up. I obviously can't turn and go upwards because the graph has to keep going down there, but I can at least maybe make this look like the left side of this parabola sort of a shape, like maybe something like this, right? Okay, so this here seems like a perfectly good picture thus far. Well, now I can take into account my third important set of information here, which is this end behavior. Notice that as my graph goes towards -infinity, I need to be lining up with the value of -2. Oh, well that's not bad. Notice this is telling me that there's a horizontal asymptote on the graph of -2. And I can perfectly just kind of sketch that in right here. Let's say this is -2. Now as I go towards -infinity, my graph is going towards -2. That's an easy addition. Well, now notice as I go the other direction, as I go towards infinity, I have to be approaching 0. Like I would have to be approaching right here. Ooh. Well, notice I can't again turn this green line and come back up because my graph has to be decreasing only. So maybe I just need to rework this part a little bit more. I still want it to go down in a parabola E sort of shape, but I want it to level out to 0. So maybe I just need to have it level out like this. There we go. This is a graph that satisfies all of the given conditions. Now, on the next exam, I am going to give you a question something similar to example 9. It'll be very, very similar. I'm not probably going to give you an example like example number 8, because again, in example 8, if you have the function, you can just type that into your calculator and you already know the picture. I'm interested if you really understand what the concepts of increasing and decreasing mean, what the concepts of concave up, concave down mean, what does it mean to have inflection points, all of that stuff. I'm curious if you know those things, so that way you can provide rough sketches of what a graph might look like. Of course, if you need help with this, the best way to do this is to try to even work through problems like example number 8 without referencing your calculator until the very end, right? Just to double check your work. And of course, if you need lots of examples of those, there are plenty of them in the worksheet for this section. The worksheet for this section is rather lengthy. I'm trying to give you a lot of stuff that you can go practice with. And of course, if along the way you ever have any questions or concerns, by all means, please feel free to let me know.